A limit is kind of what you expect a function to be doing at a point. Have you ever watched somebody walk off a platform while reading their phone? They didn't expect the platform to suddenly stop. This could have also happened walking in the other direction. They didn't expect to run into the step. Because these two sides don't agree, the limit at the edge does not exist. For a limit to exist, you need to expect the same result from both directions. On a flat area of grass, it doesn't matter if I approach from the left or the right. My expectation of the ground is going to be the same, so the limit exists. What would you expect in this case? From both directions, I am going to step in the hole, but I expect to step in the same location from both directions, so the limit still exists. Let's make this more abstract. Here are the three graphs of the previous situations. In the first, the limit of the function from the left is L, and the limit from the right is R. Notice how I wrote this. Limit x right arrow a minus of f of x equals L. This says the limit of f of x as x gets close to a from the left, or negative side of a, is equal to L. You can visually see this. Follow the curve starting from the left. The y value gets close to L. Because L is not equal to R, we say the limit as x goes to a of f of x does not exist. In the middle and bottom situation, coming from the left and right both give L, so in each case the limit as x goes to a of f of x is equal to L. The difference is that in the middle, f of a is equal to L, so the function is continuous. On the right there's a hole, but the limit is still L. Here's an example. Given the following graph, compute the limits. You should pause the video and attempt these on your own. It's okay, I'll wait. Now that you've totally tried these, let's go through them. First, the limit as x gets close to 1. From the left and right, the y values are getting closer to 3. Therefore, the limit is 3. Second, from the left and right, the y values are getting closer to 1, so the limit is 1. Don't get thrown off by the hole in the graph or the closed dot telling you that f of 3 is equal to 2. The limit is still 1. Finally, as x gets close to 5 from the left, the y values get close to 2, and from the right, the y values get close to 3. Since the limit from the left doesn't match the limit from the right, the limit does not exist. Notice, however, the limits from the left and right do exist.